Good morning. We began our study of stoichiometry yesterday by defining or describing this term. It is the calculation of quantities in chemical reactions. If I were to relate this to something in everyday life, I would say that stoichiometry is like the recipe of chemical reactions. If I wanted to make cookies, for instance, I would obtain a recipe. I would look to see how much I need of each ingredient, how many eggs, how much milk, how much sugar, and so on. I can also look to the recipe to see how many cookies I will be making, or how much will be produced from the recipe. Stoichiometry and looking at reactions is very similar. We're going to be able to see how many we need of each reactant, and how many products will be left at the end. We're going to explore this concept further today using the University of Colorado's Interactive Simulations website. You can access this site from our Honors Chemistry webpage under the Resources. Once you've accessed the site, you're going to click on Chemistry from the left-hand menu, and the chemistry simulations are listed in alphabetical order. We will be using reactants, products, and leftovers today. Once you've reached this page, you're going to click Run Now, and the Reactants, Products, and Leftovers application should open. Instead of jumping right into chemistry, we're going to continue with the food analogy and start in the sandwich shop. If I wanted to make a cheese sandwich for lunch, for instance, I would need 2 pieces of bread, 1 piece of cheese to produce 1 sandwich. So when you're working through this program, you're always going to manipulate your reactants and be able to see how many products you'll form. So this will be your recipe or your reaction. Now, what if I want to make more than just the 1 sandwich? I have a couple friends over and I want to make sandwiches for everyone. I go into my cupboard and I have 6 pieces of bread left in my loaf and 4 pieces of cheese in my fridge. So you can here change the amount of each reactant available to you, and it will automatically tell you after the reaction what you have produced. So I was able to make 3 cheese sandwiches. I'm completely out of bread and I have 1 piece of cheese left. What if we expanded this a little further and changed to a meat and cheese sandwich? So now if I were going to make a turkey sandwich for lunch, I would need 2 pieces of bread, 1 piece of turkey, and 1 piece of cheese to make a sandwich. So now we have 3 reactants and 1 product. Again, I have a couple of people over this afternoon and I'm not sure if I can make sandwiches for everyone. I go into my cupboard, I have 10 pieces of bread available and 6 pieces of meat and 8 pieces of cheese. In this instance, I'm able to make 5 turkey sandwiches. Again, I've run out of bread. I have 1 piece of meat and 3 pieces of cheese left over. We have a special name for the ingredient or the reactant that's completely used up. It's called the limiting reactant or the limiting ingredient. It, as I said, is completely used up and it limits the amount of product that can be formed. So in each of these reactions or recipes, you're going to have to identify the limiting reactant. Once you've made predictions and tested your predictions regarding cheese and meat sandwiches, I think you'll be ready to apply what you've learned to a real reaction. So you'll click on the Real Reaction tab at the top, and there's 3 different reactions that you'll take a look at: the synthesis of water, the synthesis of ammonia, and the combustion of methane. If we look at water for a moment, we've learned that all reactions obey the law of conservation of mass, meaning that we have to have the same number of atoms on the left as we do on the right. And all of these reactions are already balanced so that they do obey this law. For water example, if I have 7 hydrogen molecules available and 3 oxygen molecules, I find that I can produce 6 molecules of water. I will have 1 hydrogen molecule left over and 0 oxygen. In this case, the oxygen would be the limiting reactant. I have completely run out of it and it limited the amount of waters I can form. Once you've worked through the water examples, you'll do a few with ammonia and then finally some with methane. The one difference about the combustion of methane is now we have 2 products as opposed to 1. but it's still the same principles. If we look at an example, if I have 5 methane molecules available and 3 oxygen, I not only have 1 product but 2. I'm able to make only 1 carbon dioxide and 2 water. I have 4 methane left over and 1 oxygen left over. Even though the oxygen hasn't been completely used up, it is in the smallest amount, and so it is the limiting reactant, or what limited the amount of products that can form. Once you've worked through each of the 3 reactions, there is a game that you'll play to test your knowledge at the end. The game is 5 questions, and it's going to time you here at the bottom. Let's start a new game so our time starts over. The game settings, you should start at level 1. If you have extra time, you can play level 2 or 3. Hide nothing. And when you start, your time will start. Once you've completed all 5 questions correctly, call me over, and the first 3 students that finish in the least amount of time will receive extra credit. Good luck, and please call me over if you have any questions.